So dear students, welcome to the Adubu Learn YouTube channel. Today I am going to explain refraction of a light. In this video I am going to describe the concept of the refraction of the light, laws of refraction of a light, refractive index, important terms related to the spherical lenses, then image formation by the spherical lenses, and finally the lens formula, then magnification of a lens and power of a lens. Okay, I will move to the what is meant by the refraction. So refraction, the bending of a light when it is passes from one medium into another in which its speed is different. So let us take a simple example. Take a cup of water. A light is passed from air to water or vice versa. That means that when a light rays travels from one medium into another, the bending of the light takes place. So this is called as refraction of a light. So let us take one simple example. Take a cup of water, immerse a pencil in the water. So because of the refraction of the light, the pencil appears to be bent, or in other words, it appears to be broken. Just observe the diagram. So let us take the second example. Put a coin inside the beaker or a cup of water. So your coin position here. Due to refraction of the light, it appears somewhat above the previous one, that is the original position. This happens because of refraction of a light. So the refraction of light, it is the phenomena of changing the path of the light in going from one medium to another. So what are the rules of the refraction? The first rule number 1 says that when a light rays travel from the rarer medium to the denser medium, the light ray bends towards the normal. Suppose second rule number 2 says that when a light ray travels from denser medium to the rarer medium, the light ray bends away from the normal. Just observe the diagram. Here it is. This is the rarer medium, this is the denser medium, this is the incident ray. It falls on the refracted surface of the denser medium. So here the light ray bent towards the normal. This is the normal, that's the perpendicular line. It is bent towards the normal. Let us observe the second one. Here it is just opposite. Here the light ray travels from denser to rarer medium. Here it is the light ray bends away from the normal. So these are the two important rules of the refraction. So next one, we can discuss the refraction of a light through a rectangular glass slab. Just observe this diagram. So here it is the PQ. PQ is the incident ray falls on the refracted surface of the glass slab AB. So now here it is, this O is the point of intersection, and MN, it is normal to the surface. So when the light falls falls on the refracted surface of the AB, it is bended. So here according to rule number 1, the light ray bend towards the normal, this one, O dash. So now here the air is a rarer medium, glass is a denser medium. How to decide it is a rarer and denser? That depending upon the refractive index. The next slide you can study what is the definition of refractive index. So now second case, the light travels from glass to air, that is denser to rarer medium. Here it is the light ray bends away from the normal, that is M1, N1. So here what are the important terms? One is incident ray, refracted ray, normal to the plane, angle of incidence, angle of refraction, and emergent ray. Now we can discuss one by one. So when a ray a ray of light passes through the rectangular glass slab, it gets bent twice. Twice means one is from air to glass, another one glass to air. At the air glass interface and at the glass air interface, the emergent ray is parallel to the incident ray, that is O dash or the RS is parallel to the PQ. It is displaced through some distance called shift distance, the lateral shift. So I said now what are the important terms related to this diagram. One is incident ray. What is the incident ray? PQ. Incident ray is a light ray which travels into a medium. That is, it is a light ray. It travels from air to glass or glass to air. So here it is the refractor ray. It is a light ray which bends after refracting. That is O dash. This one. This is a refractor ray. This is incident ray. What is the normal? Normal is Mn, M1, N1. Normal is a ray which is perpendicular to the surface at point of intersection. What is the point of intersection here? O. Then angle of incidence. The angle of incidence, it is the angle between the incident ray PQ and the normal Mn. This one. So this is I is angle of incidence. Next one is angle of refraction. What is the angle of refraction? It is the angle between the refracted ray and the normal. This one R. So angle of incidence is denoted by small letter I. The angle of refraction, it is denoted by small letter R. Now comes to the medium. What is the medium? Medium is any transparent substance through which light can pass. Suppose any transparent medium, when the light can pass to the or into that particular substance, it is treated as the medium. Actually, there are two types. One is optically rared medium. Another one is optically denser medium. What is optical rarer medium? It is that medium in which the speed of light is more. That is, suppose let us consider the air or vacuum. The speed of light in vacuum, it is very high. That is 3 into 10 to the power of 8 meter per second. Second one is optically denser medium. Is that medium in which the speed of light is less. Suppose air to glass, if we consider two interface medium, air is rarer medium, glass is denser medium. Suppose if we consider glass and water, here it is glass is denser medium, water is rarer medium. That is, depending upon the speed of the light, the medium can be classified into two. One is optically rarer medium, another one is optically denser medium. So now discuss the law of refraction of a light. Let us observe this diagram, the same diagram. Here it is, OA is the incident ray. After refraction, it is bended towards the normal, that is refractor ray OB. Then I is the angle of incidence and R is the angle of refraction. There are two media, one is the air and glass. That is, the ray travels from air to glass or rarer medium to the glass. So here PQRS, it is a rectangular glass slab, and same N dash is normal to the curve. Let us discuss first law. What is the first law? Says that the incident ray OA, the refractor ray OB, and normal to the interface of the two transparent media at the point of incident, that is N dash, all lie in the same plane. The incident ray, the refractor ray, the normal to the interface of the two transparent media at the point of incidence all lie in the same plane. And what is the second law? Says that second law says that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of given color or for the given pair of media. So this law is also called as Snell's law of refraction. It is a very important law, and also it gives the relationship between I and R in terms of sin I and sin R. So what is the ratio of the sin I to the sin R? Is a constant. That constant is called as a refractive index of the media 2. That is here media 2 means the glass. Here is considered as a 1. The media 2 with respect to the air. So if I is the angle of incidence and R is the angle of refraction, then I said no, according to the second law, sin I divided by sin R is equal to constant. This constant value is called the refractive index of the second medium. What is the second medium here? Glass with respect to the first. With respect to the first means air. So now discuss the refractive index in somewhat details. So same diagram I will consider here. The medium 1 is taken as a air, medium 2 is a glass. Same thing here, incident ray is falls on the surface of the glass. It is bended after refraction. So what is the refractive index? I said already, here you have to consider the speed of the light. So ratio between the speed of the light in medium to the speed in a vacuum is the refractive index. That is, here always the speed of the light in air or vacuum, it is higher than the speed of the light in other media. So consider ray of light traveling from medium 1 into the 2. Let V1 is the speed of the light in medium 1 and V2 is the speed of the light in medium 2. The refractive index of the medium 2 with respect to the medium 1 is given by the ratio of the speed of the light in medium 1 and speed of the light in medium 2. So it is usually represented by the symbol N21. So how do you pronounce that one? Refractive index of the medium 2 with respect to 1. So what is the first number appears? That is, you have to say the refractive index of medium 2 with respect to the first. So this can be expressed in an equation form like this. So N21, speed of light in medium 1, that is, I said already, the V1 is the speed of the light in medium 1, V1 divided by speed of light in medium 2, that is V2. So this is the way we are going to express refractive index in equation form. So let us take a different way. Similarly, the refractive index of the medium 1 with respect to the medium 2 is represented as a N12. So 1, that is 1 is the refractive index of the medium 1 with respect to the 2. It is given by just opposite to the previous one. Here it is N12 is equal to speed of light in medium 2 divided by speed of light in medium 1, that is V2 divided by V1. So like that you can define the refractive index. Sometimes they may ask you, sometimes they may give N21. The N21 value is equal to some value. Then you are asked to find out the opposite one. That is, if we give N21, they may ask you to find N12. How do you find out the N12? Just like this, just observe here. I will take the pen. See now, this is given. So, N12 equal to 1 divided by, that is the reciprocal of N21 or vice versa. That is, if N21 is given value is equal to 1.2 something, whatever it may be, then N12 you have to find out N divided by that value. So what is the unit of refracting index? Does it have any unit? No, because it is, the definition says that both the speed gets cancelled. It is no, it has no unit or it is unitless. So like that you have to find out the refractive index of the medium 1 with respect to the 2 if refractive index of the medium 2 with respect to the 1 is given. Next. So, absolute refractive index of the medium is defined as the ratio of the velocity of the light in vacuum to the velocity of the light in the medium. So, this absolute refractive index is always taken with respect to the speed of light in medium. That medium is air or vacuum. So, the absolute refractive index of the medium is defined as the ratio of the velocity of the light in vacuum to the velocity of the light in the medium. Suppose C is the velocity of the light in vacuum and V is the velocity of the light in medium. Then N is the notation or the symbol for refractive index equals C divided by V. So here we discuss the refractive index, that is what are the two types. One is the absolute refractive index of a medium, another one is refractive index of the medium 1 with respect to the 2 or vice versa. I will move to the next slide. So before that, I will erase that one. Okay. So you have to know some of the important refractive index of the some common materials. Here it is refractive index always taken as a 1, water is 1.33 or 4 divided by 3, glass is 1.5, 3 by 2, diamond 2.42. These are the important material. The refractive index is taken as for air 1, for water 1.3, for alcohol 1.36, for specs is 1.5, glass 1.5 usually. It is varies from 1.5 to 1.7. So usually it is taken as a 1.5. For diamond it is 2.42. So now move to the next slide, the refraction by spherical lenses. So it is a very important one. Here also there are two types of the spherical lenses are there. One is convex lens, another one is the concave lens. So before discuss these two types, let us understand what is meant by spherical lens. The spherical lens is a piece of transparent glass bound by two spherical surfaces. So there are two types of the spherical lenses, I said already. One is convex lens, another one is concave lens. So this is convex lens. So what is a convex lens or behavior of the convex lens? The convex lens bulges outward and is thick at the center, thinner at the edges. See the diagram. So what is the function of the convex lens? It converges the light rays. See the diagram. These are the parallel rays from the opposite. It falls on the lens. After refraction, it is converges at a point F2. F2 is called as a principal focus. We can discuss later. The convex lens converts the light rays. So because of this function, these convex lenses are also called as converging lenses. So what is the second type? Second type is a concave lens. Here it is, concave lens bulges inward. Just see the difference. This is outward, this is inward. It is thinner in the middle and thicker at the edges. Such lenses diverse light rays. Just see the diagram. These are the light from the object. When it is falls on the concave lens, after refraction, it appears to diverge at F1. That is, F1 is the principal focus. Such lenses are called diverging lenses. Sometimes in the exam they may ask you differentiate between convex lens, concave lens. One is converging lens, diverging lens. Convex lens bulges outward. This is bulges inward. It is thick at the center, thinner at the edges. So like that, or even you can explain, this is more than sufficient for your that answer for the question. So now let us discuss convex lens. I said already, convex lens, they are thicker in the center than edges. Second point, lens that converges light rays, see the diagram, and it forms real image and virtual images depending on position of the object. Same as spherical mirror, here also convex lens forms the real images and virtual images depending on position of the object. What is meant by real image means the image formed on the screen, it is taken as a real image. So one of the application you can discuss later on, the magnifier. This is the magnifier. You can see the letters somewhat bigger in size because of reflection of the lens, light of the lens. So this is the convex lens. Here these are the parallel rays from the object. After refraction, they are converge the light rays at principal focus. So let us move to the next slide, concave lenses. So lenses that are thicker at the edges and thinner in the center. So what is the function? It is a diverges light rays. All images are erect and reduced in size. So this is the diagram. This is the parallel rays from the distant object. After refraction, it appears to diverge at focal point. So this is used as a demagnifier like this. Let us observe this slide. So these are the light rays after refraction appears to diverge at this point, that is the focal point. So now discuss the important terms of a spherical lens. There are two lenses, that is the concave and convex. Just observe these two diagrams. So in this first one is the convex lens, second one is the concave lens. It is terms very similar to the spherical mirror, but the difference is in the spherical mirror only one center of curvature, one principal focus, and two, that is here it is, there are two center of curvature C1, C2 and principal foci F1 and F2. Why means here lens has a two bonded surfaces. Because of that one, it has two centers and two foci. So this is R is the radius of curvature, C1 and C2 are the center of curvatures, F1 and F2 are principal foci. So this O is the optical center. Similarly for the same thing applicable for concave lens, and this one, this is principal axis. Now discuss one by one. So what are the important ones? I said already, center of curvature, this one C1, C2, C1, C2. It is defined as center of the surface of sphere of which lens is a part. Since I said already, a lens has two surfaces, so the lens has two centers of curvatures. One center of curvature is usually denoted by C1, another one is C2. What is principal axis? It is defined as the imaginary line passing through the center of curvatures C1 and C2. This imaginary line passing through this center of curvatures C1 and C2, it is called as principal axis. Aperture means it is defined as the diameter of the boundary of the circular lens. Then principal focus, the point at which the parallel rays of the light converge in convex lens and parallel rays of the light diverge in concave lens from the point is called focus or principal focus of the lens, that is F1, F2, similarly F1 and F2. What is the focal length? Same thing, so same definition applicable here also. The focal length, it is defined as the distance between optical center O and principal focus of the lens f1 or f2. Then optical center. The central point of the lens is called as an optical center. A ray passes through the optical center of the lens without any deviation. You can observe the ray, that is the line diagram of the ray from the object. The next one is the radius of curvature. What is the radius of curvature here? The distance between optical center O and center of curvature C1 is called the radius of curvature. It is usually generally denoted by capital R. So here, why it is written as a 2f1, 2fm? Just remember, in the spherical mirror, the relationship between focal length and radius of curvature. The focal length is equal to r by 2 or r is equal to 2f. So because of that one, they wrote it here. For C1 is a 2f1. Similarly, 2f2 or f1. So these are some important terms related to the spherical lens: center of curvature, principal axis, aperture, principal focus, focal length, optical center, and radius of curvature. So now discuss the image formation by lenses. So similar to the spherical mirror, here also there are 6 possible position of the object. One is at infinity, behind 2f1, at 2f1, between f1 and 2f1, at focus f1. Last one is between focus f1 and optical center O. We discuss one by one. Let us take the image formation by a convex lens for different position of the object. Let us consider the case 1. In the case 1, when the object is positioned at infinity, look at the diagram here. So this is the object AB. It is placed at infinity. The light rays from the object, these are the light rays, 1, 2, 3 like this. The image formed in case of convex lens has the following properties. What are the properties? One is image is formed at f2 on the right side of the lens. So what is the behavior, that is the image behavior and nature of the image? The image is real and image is inverted. And what is the size of the image? It is highly diminished, that is very small compared to the object size. So let us go to the number 2, case number 2. Here the object is placed behind 2f1. Look at the diagram. So this is the object AB. It is positioned behind 2f1 or behind C1. The image formed in case of convex lens has the following properties. The image is same thing, real. See the direction of the image. It is inverted, diminished. Diminished means small compared to the object size. And the image is formed between f2. So image formed between f2 and 2f2. Case number 3. Here it is. Object is placed at 2f1 or C1 in front of the convex lens. Observe this diagram. So here exactly positioned at 2f1 or center of curvature C1. The image formed at 2f2 on right side of the lens. That is, here it is. What is the nature of the image? Image is real, image is inverted, and one of the parameter is very important here. The image is of the same size as the object. So this is very important. You have to remember this image property. Sometimes they may ask you, what is the position of the object when image is the same size as the object? Means your answer is the object is placed at 2f1 or center of curvature C1. Next, move to the next position. So when the object is placed between principal focus f1 and 2f1 in front of a convex lens. Observe the diagram. So object is positioned between C1 and F1. The image is formed behind 2F2 or behind C2 on the right side of the image. What is the nature of the image here? Here it is real, inverted, but size of the image somewhat larger than object size. See here, A dash B dash is the image, AB is the object. So A dash B dash, that is the size of the image, is somewhat enlarged in size than AB. Now this goes to the next case. When the object is placed at the principal focus f1 in front of the convex lens. Just observe the diagram again. This is the position of the object at f1. The image is formed at infinity on the right side of the lens. What is the nature? So we say it is a real, inverted, and it is highly enlarged in size. So this is also important. Sometimes they may ask you, when did you get the image of the object somewhat or highly enlarged compared to the object size when your position of the object is exactly at f1 principal focus. So when the object is placed between the center O and the principal focus f1 in front of a convex lens. Just see the diagram. So this is the object AB placed or positioned in between optical center O and f1. What is the image formation? The image is formed in front of the lens. It is not on the right side of the lens. It is formed in front of the lens. This one, lateral line. So what is the nature of the image? The image is virtual. Image is erect. That is the same as object and also enlarged in size. So let us summarize this information in a table. Just observe here. So these are the position of the object we have already discussed. This is the position of the image and the relative size of the image, this one, and the nature of the image. See, in all the 5 cases, real and inverted. In the last one, it is a virtual and erect. What is the real image means? The image is formed on the screen. Virtual means it cannot form an image on the screen. So the erect means it is a upward. Suppose the object is upward in direction, same image direction also in upward. So one thing I already said that the position of the object at 2f1 or C1, you will get the same size of the image as that of the object. Now let us move to the concave lens. So let us consider first case when the object is positioned at infinity. See the diagram. The object is positioned at the infinity. The image is formed at the principal focus f1 in front of concave lens. That is, this dotted line indicates that it appears to diverge. So what is the nature? The image is virtual, image is erected, and also image is highly diminished. That is the very small in size. What is the next case? Suppose if the object is positioned between infinity and the optical center of the lens O. Again, see the diagram. This is the object positioned between infinity and the optical center. The image is formed between principal focus f1 and the optical center of the lens O. What is the nature? It is a virtual, it is a erect, and also size of the image is small in size. That is the diminished. Same thing, I summarize the information in a table. The position of the object at infinity, between infinity and the optical center. These are the diagrams. Sometimes they may ask any one position or summarize the information. So here also, what is the nature of the image? In both the cases, virtual and erect. And size of the image is, here in the second case, somewhat small in size. is a very small in size when the object is positioned at infinity. So some of the ray diagrams, just observe here. There are three different positions. First one is the light ray from the object is parallel to the principal axis. After refraction from convex lens passes through the principal focus f2 on the other side of the lens. Sometimes they may ask you write the diagram for light ray from the object is parallel to the principal axis. Second case, when the light passes through exactly the principal focus. After refraction from a convex lens, it will emerge parallel to the principal axis. Number 3, passes through the exactly at the optical center. The optical center of the lens O. After refraction from convex lens will emerge without any deviation. Without any deviation, line is exactly passed through the optical center. Similarly, the same information for the concave lens. Same thing, the light ray from the object is parallel to the principal axis. This one, it is after refraction. The ray appears to be diverse from the principal focus located on the same side of the lens. Second case, passes through the principal focus f2. That is, after refraction from the concave lens will merge parallel to the principal axis. Last one is when the light ray from the object is passing through the optical center of a lens. Here is after refraction from the concave lens will merge without any deviation. So sometimes in the examination they may ask you to draw the diagram when the light from the object is parallel to the principal axis or passing through the principal focus or passing through the optical center of the lens. Just you draw the diagram, illustrate the following methods. So what are the sign convention for the spherical lenses? The sign convention for the spherical lenses is same as in the spherical mirrors. So here it is, in the spherical mirror, what do you consider the distance measured towards the left is taken as a negative. The distance towards the right, it is taken as positive. It comes to the object height, it is upward, it is treated as a positive. It is downward, it is treated as a negative. And one more thing, for the convex lens, for the focal length is positive. For concave lens, focal length is negative. Now let us discuss the lens formula. In the examination, they may ask you derive the lens formula for a convex lens, for a concave lens. For illustration purpose, I consider convex lens. This is the diagram. So consider the convex lens with optical center O. Let F be the principal focus, FF, and small f be the focal length. This is OF in both the sides. An object AB is positioned perpendicular to the principal axis at a distance behind the focal length of the lens. This is the U. U is the object distance. And what is the nature of the image? Here you are getting the real inverted magnified image A dash B dash is formed behind principal focus on right side of the lens. So I said already, this OA is the U, OA dash is B, OF is the focal length F. Now how to derive this one? Just observe here. Let us consider triangle OAB, OA dash, B dash. These two are similar triangles. Therefore, A dash, B dash divided by AB equal to OA and OA dash. Or in other words, A dash, B dash divided by OA equal to OA dash divided by OA. Similarly, let us consider this one. OCF, F A dash, B dash. So in this, these two are similar triangles. Therefore, A dash B dash divided by OC, this one OC, and FA dash divided by OF. So just see the diagram. This OC is exactly equal to the object height AB. Therefore, these two equations written as A dash B dash divided by AB equals FA dash divided by OF. So from equation 1 and 2, I can write it as OA dash divided by OA equals FA dash divided by OF. So what is FA dash? See the diagram. OA dash minus OF, or OA dash means what? This is U. Why it is taken as a negative? Because the sign convention, any distance measured towards the left, it is treated as a minus. That's why it comes here minus U. For image distance, it is taken from the lens towards right. That's why it is a positive. So here OA dash, what is OA dash? V minus F. F means small f means focal length, OF. So just rearrange the equation, you will get VF equals minus UV plus UF. Same thing, dividing all the side or both side by UVF. So you will get the equation 1 by U equal minus 1 by F plus 1 by V, or 1 by F equals 1 by V minus 1 by U. This is the lens formula for convex lens. So next one is the magnification of a lens. So it's similar to the magnification of a mirror, same definition. The magnification M of an image is the ratio of height of the image to the height of the object. So it is denoted by capital letter M equals image height divided by object height. So here also number is a dimensionless ratio, because both are length gets cancel each other. It does not have any units. Magnification of the lenses also does not have any unit. Similarly, the refractive index of a lens does not have any unit. So if you want to write it in terms of image distance, it is M equal to V divided by U. This is the image height and the object height. Or some books they're taken as a HI divided by HO, like that. Next one is important parameter is called power of a lens. The power of a lens is the reciprocal of its focal length. That is denoted by capital P is equal to 1 by F. So M means it is the unit of the focal length is in meter. So then SI unit of the power is the diopter. It is usually denoted by capital letter D. One diopter is the power of a lens whose focal length is 1 meter. Same thing, the power of a convex lens is positive because F is also positive. The power of a concave lens is negative because F is negative for concave lens. So what are the uses of the convex lens or application of the convex lens? One is it is used as a camera, magnifying glass. This is the microscopes, telescopes, and it is you can treat it as human eyes, spectacles, rear view mirrors. These are the some of the application of the convex lens. It is used as a camera, magnifying glasses, microscopes, telescopes, human eyes, spectacles, and rear view mirrors. What are the application of concave lens? It is used as a flashlights, lasers, peepholes, reflectors, and street lights. These are the some of the applications of concave lens. Thank you for watching this video. Like the video for YouTube algorithm. If you have any doubts, please comment in comment section. Thank you once again.